Hello everyone. In the beginning of the class, let us see new announcements. Okay, the first new announcement is May 3rd, 2022 class videos uploaded. Hello everyone. I have uploaded class videos of May 3rd. 2022 to YouTube. Their URLs are this, and this. Best regards, Wei Zhen. Okay, the next announcement is the handout of Chapter 2 has been updated. Version 2022-0505. Hello everyone, I have uploaded the latest version of the handout of Chapter 2 to Equals 2 website. The location and the file name are Equals 2 website, wireless communications and machine learning, course content, handouts, Chapter 2 handout 2022-0505.pdf. Best regards, Wei Zhen. Okay, next let us look at the progress of the last class. In the last class, we have taught to Chapter 2 handout, page 47, problem 19. Solution, vice versa. Okay, let us go to problem 19. Okay, not here. Okay. Okay, so let us search for page 47. Oh, sorry. Page 47. Okay, here, and search for problem 19. Okay, here. Okay, problem 19. What is a partial order? Okay, why do we need to know what is a partial order? Okay, because okay, partial order appears in the solution to problem 18. What is a total ordering? And why do we need to know what is a total ordering? Okay, it is because total ordering appears in the solution to problem 17. What does field is ordered mean? Okay, and why do we need to know what does field is ordered mean? Okay, it is because, okay, let us go to the four previous slides. Okay, I think I had missed it. So let us search for field is ordered. Okay. Okay, so field is ordered appears in the solution of to problem 13. What is a locally convex space? And why do we need to know what is a locally convex space? Okay, let us search for it. Locally convex space. Okay. Okay, because a locally convex space appears in the solution. Okay, to problem 4, what is a subgradient? And why do we need to know what is a subgradient? Okay, because a subgradient appears in the solution to problem 3. What is subdifferentiable? Okay, and why do we need to know what is subdifferentiable? Okay, because it appears in the solution to problem 2. Okay, what is stochastic gradient descent? Okay, so why do we need to know what is stochastic gradient descent? Okay, it is because, okay, let us open the slides of chapter 2. Okay, and search for the stochastic. Okay, because the term stochastic gradient descent appears on page 47 of the slides of chapter 2. Okay, let us go back to page 47 and problem 19. Okay. Okay, problem 19. What is a partial order? Solution. A partial order relation is a homogeneous relation. Okay, we will explain what is a homogeneous relation later. That is transitive and antisymmetric. We will introduce what are transitive and antisymmetric later. Okay, there are two common subdefinitions for a partial order relation. For reflexive and irreflexive, okay, we will introduce what are reflexive and irreflexive later. Partial order relations, also called non-strict and strict respectively. Okay, the two definitions can be put into a one-to-one correspondence. Okay, we will introduce what is a one-to-one correspondence later. So for every strict partial order, there is a unique corresponding non-strict partial order and vice versa. Okay, the term partial order typically refers to a non-strict partial order relation. Okay. Next, let us see the definition of non-strict partial order. Okay, a reflexive, weak, or non-strict partial order. Okay, these three terms means the same thing. It's a homogeneous relation. Okay, we will introduce what is a homogeneous relation later. Smaller than or equal to on a set P that is reflexive, antisymmetric, and transitive. Okay, we will soon introduce these three adjectives in the following points 1, 2, 3. That is, for all ABC in P, it must satisfy 1. Reflexivity. A is smaller than or equal to A. That is, every element is related to itself. 2. Antisymmetry. If A is smaller than or equal to B, and B is smaller than or equal to A, then A is equal to B. That is, no two distinct elements precede each other. Okay, 3. Transitivity. If A is smaller than or equal to B, and B is smaller than or equal to C, then A is smaller than or equal to C. Okay, besides, a non-strict partial order is also known as an antisymmetric preorder. Okay, we will introduce what is a preorder later. Okay, next let us see the definition of a strict partial order. Okay, an irreflexive, strong, or strict partial order is a homogeneous relation smaller than on a set P that is irreflexive, asymmetric, and transitive. Okay, we will introduce the meaning of these 3 adjectives in the following points 1, 2, 3. That is, it satisfies the following conditions for all A, B, C in P. Okay, what does it mean? Okay, it means an irreflexive, strong, or strict partial order. Okay, first, irreflexivity. Not A is smaller than A, that is, no element is related to itself, also called anti-reflexive. Okay, 2. Asymmetry. If A is smaller than B, then not B is smaller than A. Okay, this means that B is smaller than A is wrong or is false. Okay, 3. Transitivity. If A is smaller than B and B is smaller than C, then A is smaller than C. Okay. Irreflexivity and transitivity together imply asymmetry. Okay, what does this mean? Okay, it means that if we have here condition 1 irreflexivity and condition 3 transitivity, then we will have condition 2 asymmetry. Okay, also asymmetry implies inflexivity. Okay, let us see. Okay, asymmetry implies irreflexivity. That is, condition 2 implies condition 1. Okay. In other words, a transitive relation is asymmetric if and only if it is irreflexive. Okay, what does this mean? This means if condition 3 is true, then condition 1 and condition 2 can imply each other. Okay, or in other words, condition 1 and condition 2 are necessary and sufficient condition of each other. Okay, so the definition is the same if it omits either irreflexivity or asymmetry, but not both. Okay, what does this mean? It means that we can delete condition 1, okay, and the definition is remains the same. Or we can delete condition 2, only have condition 1 and 3, and the definition will remain the same. Okay. A strict partial order is also known as a strict preorder. Okay, we will see what is a strict preorder later. Okay, let us see an example. On the real numbers R, okay, I have told to you this R denotes the set which contains all real numbers. The usual less than relation, okay, smaller than, is a strict partial order. Okay, the same is also true of the usual greater than relation. Okay, this greater than on R. Okay, you can check this you can check this example according to the definition of the strict partial order. Okay, and you will find R with the less than relation is a strict partial order, and this is also true for the relation greater than. Okay, problem 20. What is a homogeneous relation? Okay, why do we need to know what is a homogeneous relation? Okay, because it appears, okay, here, homogeneous relation, okay, in the solution to the previous problem, problem 19, what is a partial order? Okay, next let us look at the solution. In mathematics, a homogeneous relation, also called interrelation, over a set X is a binary relation over X and itself. That is, it is a subset of the Cartesian product. Okay, I have introduced what is the Cartesian product. Okay, if you forget, please review the handout of chapter 2. Okay, and you can search the Cartesian product in this handout. X times S. Okay, this is commonly phrased as a relation on X or a binary relation over X. Okay. Okay, let us see an example. An example of a homogeneous relation is the relation of kinship. Okay, we will explain what is a kinship later. Okay, where the relation is over people. Okay, let us see problem 21. What is a kinship? Solution: the relationship between members of the same family. Okay, it is called the kinship here. Okay, problem 22. What is a one-to-one correspondence? Okay, why do we need to learn what is a one-to-one correspondence? Okay, because it appears in, okay, appears here. Okay, one-to-one correspondence in the solution to problem 19. What is a partial order? Okay. So, solution. In mathematics, a bijection, also known as a bijective function, one-to-one correspondence, or invertible function, is a function between the elements of two sets, where each element of one set is paired with exactly one element of the other set, and each element of the other set is paired with exactly one element of the first set. Okay. So there are no unpaired elements. Please see figure 21. Okay, let us see figure 21. Okay, I need to Okay, make this figure smaller. Okay, like this. Okay, please see this figure. Okay, figure 21. A bijective function f is from x to y. Okay, f is a function from x to y, like this. And this denotes the set x. And this denotes the set y. Okay, where set x is 1, 2, 3, 4, and set y is a, b, c, d. Okay, you can see that the set x, has 4 elements, 1, 2, 3, 4, and the set y also has 4 elements, d, b, c, a. Okay. So for example, f of 1 is equal to d. Okay, here f of 1 is equal to d. So similarly, f of 2 is equal to b, f of 3 is equal to c, and f of 4 is equal to a. Okay, so this is a one-to-one correspondence. Okay, let us go back to, here, figure 21. Okay, so next, let us see problem 23. What is a preorder? Okay, why do we need to know what is a preorder? Okay, it is because the preorder appears, okay, let us see, here. Okay, appears here. And here is the solution to problem 19. What is a partial order? Okay, let us go to the problem of preorder. Okay. So problem 23, what is a preorder solution? Let us see the formal definition of a preorder first. Consider a homogeneous relation smaller than or equal to on some given set P. Okay. So that by definition, smaller than or equal to is some subset of P times P. Okay. Here times is the Cartesian product. And the notation A is smaller than or equal to B is used. Okay, in place of the pair A and B, this pair A and B is in the set smaller than or equal to. Okay, then smaller than or equal to is called a preorder or quasi-order if it is reflexive and transitive, that is, if it satisfies. Okay, 1. Reflexivity. Okay, A is smaller than or equal to A for all A in Pn. 2. Transitivity. If A is smaller than or equal to B, and B is smaller than or equal to C, then A is smaller than or equal to C for all A, B, C in P. Okay, a set that is equipped with a preorder is called a preordered set or proset. Okay. For emphasis or contrast to strict preorders, a preorder may also be referred to as a non-strict preorder. Okay. If reflexivity is replaced with irreflexivity while keeping transitivity, then the result is called a strict preorder. Explicitly, a strict preorder on P is a homogeneous binary relation smaller than or less than. Okay, it is 25 minutes. Let us take a break.